So we are given that we have a cyclic quad here, which is PQRS, PQRS, and we are given that PQ is equals to PR. We are given that PQ is equals to PR, right? So now, from there, guys, yeah, I think that's all the information that we need for us to answer this question. So, what we are required to prove, we're required to prove that our S3 is equals to S4. So let's start. Let me just zoom my thing over there now. Right. If you can see properly, we have angle S3, which is equals to PQR, and this will be exterior angle of cyclic quad. This angle we have S3, which is equals to PQR, that angle over there, exterior angle of the cyclic quad, and we have S4, this angle, which is equals to R3 over there, and angle S4, which is equals to angle R3. Reason being angles in the same segment. Right. From there, from there we have R3. If you guys can check properly, we were given that PQ is equals to PR, right? So therefore, I can say this angle is equal to that angle. Let's go write it down. PQR, that angle, angle R3, and reason will be PR. I don't know how you guys write this, but this is how I normally give my reasons. PR is equals to PQ, and we can say angles opposite equal sides. So, since I have this, therefore I can say angle S4, my S4, that angle over there, the one that I indicated over there. I can say my sorry, my S4 is equals to PQR, right? And what's the reason behind it? Because each of them are equal to angle R3. PQR is equal to S4 because they both are equal to angle R3, right? So from there, I can say, but angle S3 is equals to P angle QR. Let's go check it. Look at this. Angle S3, this angle is equal to this angle. And what's the reason? The reason is because this is a cyclic quad, guys. Remember, that's a cyclic quad. So this is an exterior angle of a cyclic quad, which is equal to that. So you can write the reason over there and say the exterior angle of cyclic quad. So therefore, in conclusion, I can say my S3 is equals to S4 because each they are equal to PQR. Done. Now, let me remove this. Now, let me erase my question. The next question. Prove that SMRC is a cyclic quad. Let's go on our diagram. What do we have on our diagram? S is here, M was M. S M R C. So guys, if you are given something like this and they require you to prove that this is a cyclic quad, let's say on this part, RTP, required to prove that SMRC is cyclic. I'm just going to write cyclic, guys. Ne? So we can do this by saying, we can go and try and prove that this angle over here is equal to that angle over there. Now let's start. Guys, can you see CRM? CRM, this angle, it's equal to what? Is equals to PQR. Do we agree? So let me write that down. My CRM is equals to PQR. Why? Because that's a tangent chord theorem, right? That's a tangent chord theorem. This, we have a tangent over there, we have a triangle over here, and then therefore this is equals to that over there. Right. Let me just clear this. Right. That. Right. Now that we know that CRM is equals to that, angle R3, this angle over here, we know that R3 is equal to PQR, this angle right here. So, why? Because those are angles that are opposite equal sides. So now that we know that CRM is equals to PQR and angle R3 is equals to PQR, so therefore I can say CRM is equals to angle R3 because each they're equal to what? PQR. Now that I know this, let's see. Now that I proved that R3, which is this angle over here, is equal to CRM. CRM is equals to the angle over there. Therefore, okay, wait, let me say but angle S4, we just proved this. Angle S4 is equals to angle, angle S4 is equals to angle R3, sorry. Angle S4 is this angle, and it's equals to that angle. This angle is equals to that angle. Reason why? Angles in the same segment. So, how do you know that? It does a bow tie. Yeah, it touches a circle, touches a circle, touches a circle, touches a circle, and it forms a bow tie. Da, 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 da. Right? So, now that we know this part, therefore, angle S4 is equals to CRM. How, guys? We proved that. So now S4 will be equal to SRM. Why? Because each they're equal to angle R3, right? So therefore SMRC is a cyclic quadrant. Done. Now the last question. We are required to prove that RP is a tangent to what? Is a tangent passing through PSA, meaning this line RP over here, this line is a tangent passing through touching through PSA at P. So it's a tangent at this point, and then it's passing through P. This is P. P S A. Now let's try it. Right. Let's go. Let's go, guys. Guys, let's start here. Do you guys agree with me that angle P2, this angle, is equal to no, not that angle. Angle S4, this angle over here. Do you guys agree with me that this angle is equal to that angle plus that angle? Let's go write that down. Angle S4 is equals to angle P1 plus angle A2, reason being exterior angle of triangle, because that's an exterior angle of a triangle, right? Also, angle S3 is equals to what? This angle, S3, is equals to that angle plus that angle. Ah, now I see the direction. Is equals to angle R2 plus angle P2. Also, exterior angle of a triangle. Now that we know this part, now that we have proved already that this and this are equal, right? So therefore, we can say angle S3 is equals to angle S4. Proved. So now that we know this part, I can take this and equate it to that because my S3 and S4 are equal. So therefore, angle S4 or S3 is angle R2 plus angle P2, which is equals to S4 angle P1 plus angle A2. Right. Now that we are here, guys, guys, do you agree with me that angle P1, this angle is equal to angle P2? Let's write that down. Angle P1 is equals to angle P2. And what's the reason? The reason is tan chord theorem. So therefore, if this is equal to that, therefore this will be equal to that. Therefore, angle R2 will be equal to angle A2. Yes, R2. What did I do? Oh, that's P2. This is R2. Sorry. This is R2. Sorry, my bad. Angle P1 is equals to angle R2. And therefore, if angle R2 is equals to angle P1 over here, if this is equals to that, therefore P2, which is this, will be equal to A2, that. So therefore, angle P2 will be equal to angle A2, right? So therefore, we have proved that as long as you have proven that this is equals to that over there, so therefore you've proven that this line RP is a tangent to circle that passes through this point. So therefore, let me just write my conclusion. Therefore, RP is a tangent to circle PSA. PSA.